Okay, let's tackle a huge question for self-driving cars. How do you actually prove they're safe?
I mean, how can you possibly test for every jaywalker, every weird weather event, or just other drivers? The problem? The real world is just messy. It has a nearly infinite number of scenarios. So a German research project called VV Methods, or VVM, decided to take this challenge head on. And their goal wasn't to build a car. It was to build a recipe for proving a car is safe. So how do you tame infinity? Well, their big idea was you don't test for it. You define it. First up, you define where the car can operate. This is its operational design domain, or ODD. You know, setting the ground rules. Highways only, good weather, and maybe under 70 miles per hour. Once you define those boundaries, you can start breaking down reality into finite, testable scenarios. These are what they call core scenarios, a set that represents the biggest challenges within that domain. This creates a whole blueprint for safety, built on 4 interconnected perspectives. Let's break it down. Perspective 1 is global development and V&V. This is the master plan, from big safety goals to the actual car. Second, we have scenario-based development. Here's where those core scenarios are used to really test the system. Third is risk management. This part is all about constantly analyzing hazards to keep risk acceptable. And fourth, safety argumentation. This pulls all the evidence together to build a logical case for why the car is safe. These 4 perspectives all work together towards one single goal, something called explainable safety. And this shows it perfectly. On the left, you've got the theory, and on the right, the practical framework. So all the data and test results, they're used to build a structured, evidence-based safety case. See, it's not just enough for a car to be safe. You have to be able to prove it. So to sum up, you can't test for infinity. Instead, you define the domain and build a logical, provable safety case. This whole methodology is a massive step forward for trustworthy AVs, but there are still challenges. Big future challenges include the role of AI, remote operation, and how cars can learn from each other in the field. Which leaves us with one big question. As cars get smarter, can our methods for proving they're safe keep up?